All right, I think it's time for us to kick it off. So my name is David Klebanov. I wanted to welcome everybody. Good morning, good afternoon, good evening, wherever you are. I lead product marketing for Alkira, and today we have a pretty exciting webinar for you guys. As you know, we're collaborating between HashiCorp and Alkira, and today we have two distinguished speakers with us today, William and Mike, to talk about the essence of our collaboration and what does it mean to really kind of modernize the network and network delivery in this cloud era, and how infrastructure as code plays a role in that. So I'll let you guys introduce yourselves, give a bit of a brief bio on yourself to the audience. So go ahead.
My name is William Collins, and I'm a principal cloud architect with Alkira. And before joining Alkira, I worked for over 15 years across quite a few big enterprises, doing everything from network engineering, compute-related stuff, to a lot of automation, a lot of data center-focused building. So, on to you, Mike.
My name is Michael Tharp. I'm the Senior Solution Engineer here at HashiCorp. I've been here for about 3 years now, and prior to this, I spent over 20 years as a practitioner. Let's talk a little bit about Terraform. So many of you may be familiar with Terraform. If you're not, Terraform really is an infrastructure as code tool, right? We define our infrastructure as code, and then we're able to realize that once we execute that code. So there's a lot of benefits behind that. We'll talk a little bit about that in the next slide. Some folks may not realize that there actually is an enterprise grade solution for Terraform. So we have Terraform open source, and we also have Terraform Cloud and Terraform Enterprise. So when we start talking about some of those use cases, obviously infrastructure as code is job one, right? Whether we're talking about open source or whether we're talking about enterprise, infrastructure as code, job one. When we start to scale up, though, we start to see these challenges of larger organizations. So things like compliance and management and self-service, and we actually can address those with our cloud and enterprise products. So that really is kind of the high-level overview. Let's talk a little bit about infrastructure as code. So, like I said before, the benefits for infrastructure as code are pretty vast, but to kind of sum them up, being able to take our code and define infrastructure, and then being able to see kind of what's going on with it, being able to roll forward and roll back based on things like failed builds is a huge thing. And we've seen this in the development environments for years, right? So we as we're developing and we're writing application code, and we cut our applications, we say, oh, we've got a bug, we can roll forward, roll back very easily. We want to be able to do that same thing with infrastructure. And Terraform really allows us to do that. The other thing that it does is it makes it very human readable, right? So this idea of kind of complex code, we don't have to worry about that with Terraform, which gives us documentation along the way as well. So whether we're talking about future configurations or past configurations, we're able to see what kind of configurations we have, what kind of infrastructure we're deployed, and really kind of where we're going. So if we have failed builds, we can kind of recover from there, as well as being able to really unlock Terraform with open source providers. It is a core plus provider model. So essentially, Terraform takes the code and compiles it together, but then we use providers to be able to connect and securely integrate with different things like Alkira or AWS, GCP, or Azure. And this is really an open source part of our ecosystem where we contribute, as well as the providers, people like Alkira will contribute, and then we actually have individuals in the community that contribute as well. And really what this does is this makes it so that Terraform can be very versatile and work with a lot of different technology and really support any infrastructure. So talking specifically about the provider, obviously we're here today to talk about Alkira, and Terraform is a really strong partner in that regard. Obviously, Alkira is a HashiCorp technology partner, and as far as that, the ecosystem and the integration that we have with Alkira is really vast. So being able to get a hold of all the resources and all the different feature-rich technologies that Alkira has, we can actually reach in with Terraform and actually integrate very tightly. So just know that that's available, and that it'll make this configuration much easier. So lastly, talking about Terraform, a lot of folks, if you're familiar with Terraform and you're using maybe open source today, and you're saying, you know what, I don't know what the point is of when I start to look beyond open source, right? So it's just important to know that open source is built around the individual, right? It really was designed for the individual. So I'm running on my laptop, I'm writing code, I'm deploying infrastructure. And if as you start to scale up, right, you move beyond that infrastructure as code, and you start to realize that you have other things you need to deal with, right, as you start to become a larger organization, or maybe you start to scale this out to a much larger organization. So we'll have things like compliance and management, all the normal enterprise features and functionality, and ultimately being able to do things like self-service and really allow other folks who maybe aren't Terraform people to be able to do those configurations. This is really all around organizational complexity. So as your organization becomes more complex, the needs become more complex. This is where we start to look at moving away from open source and looking at Terraform Cloud or Terraform Enterprise. Just know that that's available, and that really is kind of the decision point. So from there, I'm going to turn it over.
Thanks, Mike. So before getting into anything further with like automation side of things, I want to like take a look back and look at the enterprise journey. You know, cloud comes along, and you know, what are the challenges that a lot of enterprises have been going through and are continuing to go through? So the first thing that tends to happen is you have an enterprise and all of their applications are hosted in their data center. And cloud comes along, and an enterprise is going to want to modernize that existing portfolio using the public cloud. So generally what happens is they'll basically go in and profile all their applications, and they'll take the lowest hanging fruit. You know, what's an application that's not critical, something that we can go through and test and maybe kind of get wrong, but we learn a lot of lessons from it. And then we take those lessons, and as we go up the stack to our more important applications, you know, we become seasoned in doing this. So the first application that moves, or maybe the first few, it may not even be the whole application. It might just be a front end. And then that front end is going to be using data and reusable services that are back in the data center. So you have to have connectivity from that enterprise to the cloud. So going through and doing this, you're going to also have at the same time, you know, enterprises aren't going to stop building applications. They're going to have greenfield applications, new stuff that's coming down the pipeline. So these new greenfield applications are going to be born in the cloud. They're going to be using cloud native constructs. They're going to be more modern, of course, you know, because we're just building them now. And we don't have a lot of, you know, baggage that, you know, we built over many years back in the data center that's going to hold us back. So looking at that, those greenfield applications, a lot of times, from what I've seen, and this is practical too. I went through this, you know, in an enterprise when I worked for an enterprise, or a few of them actually. But those greenfield applications are most likely going to have connectivity back to the data center too, because a lot of these large, vast data sets that exist back in the data center, you can't just say, okay, I'm just going to move this to this cloud and that cloud and here and there. It's a lot of data. So if an application moves to the cloud, it's really hard to peel back just the data it needs. Or maybe, you know, the data is used across all the applications. There's specific data sets. So provide, you know, there's some challenges there. And this whole thing of cloud modernization also, one thing you'll hear a lot of when you start going on this journey is there's I think AWS originally came up with this. I can't remember. It's been a while back, but there's this 4 R's. So you have rehost at the beginning, and rehost is just basically taking an application the way it is in the data center and just forklifting it and, you know, throwing it in a cloud provider as is. You're not making any changes to the delivery process. You're not making any changes to the architecture, the code base, nothing. And so that's kind of the first iteration. And then the second iteration is re-platform. So going into re-platform, you're actually going to change some things. You know, maybe you change the database. You know, say you're in Azure and you use Azure Managed SQL, and you're going cross-region. You want to tap in on those DR capabilities, and you have asynchronous cross-region connectivity there, synchronization rather, for your data. You know, but the application code kind of remains unchanged. But maybe with deploying the application, you start to peek into, CI/CD a little bit. You want to get infrastructure as code going. So you incorporate that as well. And then going to the refactor stage, or re-architect rather, is really just top to bottom, taking it and redesigning it. You're talking major changes to code base, storage, all the pieces, and getting really in depth with infrastructure as code. So these are some of the challenges with just what it takes to move an application, thinking through some of these things. And if the application isn't a fit for cloud, there's always retirement. So it may retire and it may just sit in that data center and run until one day it's retired. Or it might be forklifted to cloud and plop down, and it may retire in a cloud provider without any further changes to the application. So these are some challenges that enterprises are going through, and not to mention every org is one acquisition away from multi-cloud. So all these integrations that happen, mergers and acquisitions, and I remember back in the day, or I say back in the day, but this is still now even, companies built their product, everything that they do, the bread and butter of their business, in a data center. And when you acquired a company, you acquired that data center, you acquired all that intellectual property and the people, the skills, the staffing, all the everything. And that was part of the acquisition. And a lot of companies nowadays, they're not saying, hey, we're going to go build, what's the first thing we need to do? We need to go build a data center so we can, build an application in it, or, create a product. No, they're saying, hey, what is the cloud provider to go to? How are we going to do this? We want to use that in the full functionality of cloud to scale something. So all these new companies are getting created in public cloud. So that means that when you acquire one of these companies, you're most likely going to acquire something that's been built in the cloud. And what if it's not the cloud provider that you happen to be in? Well, congratulations, you're now multi-cloud. So going on to delivery. So network practitioners, I was a network engineer for a long time, and I was in the CLI all the time with the rest of them. And this model of managing networks is just changing. So the DevOps practices and a lot of lessons learned from cloud adoption, from infrastructure as code, they're making their way into the network space. So taking on those DevOps practices for deploying and managing network infrastructure is becoming critical. And this information nugget down there, 92% of enterprises have a multi-cloud strategy, 45% are integrating data between clouds today. And that was Flexera 2021. So that's gigantic. So traditional approach for deploying networks. I remember back, when I was network engineering, a common, just a very common design pattern is hub and spoke. We'd have data centers and we'd have sites connecting to those data centers. And at the site, you would have maybe 2 routers, 2 switches. You'd have an A side and a B side, active and standby. And you'd have maybe an IGP like EIGRP, and then you'd redistribute routes into BGP and then connect that site back to your data center. And this is kind of what I'm looking at right here in this diagram. So going through and taking that appliance-based approach to network design in the cloud, we're talking, every network, every VPC is going to get an appliance. You've got to design around that active standby. It's standard for high availability, and you're really looking at an IaaS-based fulfillment model. And in talking scale here, this is what you're looking at is just 2 spoke VPCs going to a hub. But this takes I guess, sort of a scale up approach rather than a scale out. And thinking of, okay, I have a design specifically for spokes, I have a design specifically for hubs, and this is just one region of one cloud provider. Okay, well, I'm gonna have to do this again for another region. And then, okay, we have multi-cloud. So I have this whole other, hub and spoke model for Azure, for GCP. And then, okay, what happens when I need to connect one spoke in one cloud to a spoke in another cloud? You know, so as use cases come along, it gets increasingly difficult. And looking at some of the costing as well, so I may go out and I may get some licenses for a certain type of appliance or a router or gateway. And you know, I have maybe I want to scale out to a certain number, and I get that bill of materials, and I have some, you know, extra features that I want with these devices too. So I have that cost, and I think, okay, I'm done. You know, but then I deploy this model, and then as you know, 5 or 6 months go on, you know, I realize, okay, I have like the cloud platform spend that should have been part of this as well, and I really didn't think that through. So there's two sort of costing models there. And then, of course, you know, thinking through the complexity aspect of, you know, again, this is just 2 spokes. What happens when this is 100 in a single cloud, or, you know, multi-cloud, you know, adding other cloud networks, and then thinking through the appliance lifecycle, software updates, CVEs, like rapid upgrades for security considerations or vulnerabilities. So the managing and the care and feeding can be complex at scale. Now, Alkira takes a little bit of a different approach here in that, like back to the AWS example, a spoke is just another VPC. There's no separate design. I don't have these 2 separate designs for hub and spoke. It's just another network. And then, you know, another cloud provider's network, so say GCP VPCs or Azure VNets, you know, that's just another network that I'm connecting. You know, I don't need any physical hardware or appliances for the routing. And I put a star next to this one because it's actually getting to do this on the customer side was, you know, going from one design model to another. You know, this is really awesome in that high availability here is built into the service. So I'm not having to go through and plan putting different appliances in different availability zones and setting up, you know, going through and setting that up. You know, it's built in, so I get that capability without having to do the extra design work and have that extra overhead. So this basically enables a scale out approach rather than scale up. And so looking at this diagram and looking at that information nugget down there, 77% of respondents to this O'Reilly survey adopted microservices, you know, with 92% experiencing success. Now that's huge. And I know from my own experience in the enterprise, microservices are hot right now. Kubernetes is getting really, really popular, and a lot of greenfield stuff is getting built on containers. And even a lot of legacy stuff is getting modernized into, you know, coming out the other end as microservices. So this is definitely really popular, and there's a lot of reasons why. But looking at this diagram, so I have legacy applications in the data center. You know, maybe I have some lift and shift in Azure, and then I have this this proliferation of microservices everywhere. I've got them in 3 clouds, and I even have them in my data center. And to connect all these things, you know, we have Alkira here is like a base infrastructure for our network and our security for layers 1 through 4. So let's call it network bedrock. And then coming in, you know, with this microservice architectures, having a service mesh to handle layers 4 through 7, integrating Alkira with, you know, a service mesh like Console Connect is seamless. Really easy to do. You have your network bedrock, and then you run your service mesh transparently right on top. And this gives you your controls for how different parts of applications and, you know, connect and share data encrypted. So moving on, I wasn't going to include this picture, so I got to give a little background on why I put this in here. So my wife and I share photos, like we have Google Photos. So whenever I'm scrolling through my photos on my phone, I also see the pictures that she took. So probably about a few weeks before I started putting together these slides, I came across this picture. And I look at it and I'm like, what was I doing here? And in my right hand, I have a handsaw. In my left hand, I have what appears to be a 2x4. And then behind me is this really nice DeWalt double bevel sliding compound miter saw. It's real nice. And I even have I got a Diablo blade, 80 tooth, high density carbide and like titanium, really nice blade. You know, this thing is made for precision cuts. You know, it's made to get the same cut every time. It's got all the measurements to make more complicated cuts, you know, for, you know, neat projects. It's a real good system that I have going on there, which leads me back to my question. What am I doing with a handsaw right here? And what this sort of reminded me of was looking at this statistic, 81% of participants in this net DevOps survey allow manual changes via CLI. And again, I was a network engineer. I was there. I was in the CLI a lot. But one of the things with approaching, you know, especially getting to the cloud native delivery, the more things that you do manually, you end up causing a lot of configuration drift, a lot of variety across the different networks that you connect. And the more snowflakes you have in the environment, the harder it is to manage and make changes in the future, because you can't predict what is going to happen. So this, you know, I say it now, but a lot of organizations may still do this today, like going into the cloud portal and making changes, adding gateways, doing, you know, maybe changing some stuff, and then, you know, logging into cloud firewalls, cloud routers and everything. This is really sort of becoming an outdated way of doing things. And as far as the how, you know, network design, at least as far as, you know, as long as I can remember, has sort of consisted of this define, design, and deploy methodology, where you're defining your design in PowerPoint. You're going through and saying, hey, I'm meeting all these requirements and I'm doing it this way, and you build some visuals in Visio, and then you store them on a SharePoint. And then you go to the design phase and you're putting your requirements in Word, you know, or not your requirements, but your all your standards in Word documents for this design. And then maybe you have some templates in Excel, or maybe even some text files, and then, you know, maybe you even export those to PDFs to send them around so nobody can change them. And then when it comes time to make that change, you're getting on the phone with the change advisory board or the sheriffs in town, and you're sitting there and you're trying to come up with a change window that's at least like a month out in the future, where you're sitting down and at like 2 a.m. or 3 a.m. and you're making a change manually. You know, that's, you know, these text file configurations that are attached to a change order that, you know, comes in window. So you may have an ops team that does that, or you may have to do it yourself. But then you make the change, and then life goes on. So let's what, you know, how could this get better here?
I must say, William, this was a phenomenal example of how the world is moving forward. Just wanted to interject for a second. I love that slide.
Appreciate it. So let's think about the future. You know, what could it be? So, you know, that, I guess the last slide wasn't, you know, what is modernized delivery? It was really what is not modernized delivery. So looking at this, when you think of that CLI-based approach, and the CLI was never made to be automated. It was made to have a keyboard at the other end with a human typing things in and copying things in. That's just the way it was made. That's what it was intended to do. Whereas like software-oriented APIs, they're intended to have, you know, a lot of software to software communication. And looking at something robust like Terraform Cloud, you know, having a good Terraform provider that integrates with your product, what it does is it's going to give you a consistent interaction surface for your multi-cloud networking, or all your networking that you want to connect. So connecting SD-WAN through the platform, data centers, if you even want to do an IPsec tunnel, whatever cloud provider you're in, connecting all these things together through a single provider, single interaction surface is going to really help start reducing that friction and that configuration drift and start working towards more standardized design patterns. And then having these APIs that are available for Alkira, everything you can do in the portal, you can do through the API, and the Terraform Provider is driven from the API. So good parity there. So this is the with, and going down to the how, DevOps toolchain. So having tooling parity across teams is just a major win, because what tends to happen in the enterprise space is you'll have, like, I'll just use a generic example, but like server engineering is going to do it one way, network engineering is going to use a different set of tools, security engineering is going to be using, you may not even know what they're using, so it might be secret. So a lot of differences and variance there. And what that ultimately does is create these silos, and it prevents meaningful work from happening to the application or the initiative that the business is trying to drive. So changing direction to like what Mike talked about earlier is, building this declarative infrastructure in these human readable files. So declarative configuration, which what this really means is, instead of like deploying an appliance and then going out and configuring it at runtime after it's already going, declarative is basically bringing that into the build pipeline and building it and then deploying it, configuring it at build time and then, pushing it out. And then you're using version control to do this for all of the infrastructure. So all the changes are tracked in version control. So this is great in the sense that, like, let's say I sit down with security and they're deploying policy with infrastructure as code. It's in version control, they're using Terraform, and then I deploy network. I have my network policy and my network configuration, and let's say we're both using the Alkira provider, and this is great because with this level of collab, it allows us to shift our thinking to whole environments and not sets of devices. So all that whole environment that underpins an application or a service, we have in this repeatable infrastructure as code that we can deploy new iterations of with these pipelines we've created or workflows. And my last slide here, looking at, better together, journey to the cloud network operating model. So the cloud operating model is an interesting and very important concept. So when cloud starts getting real within a company, like at the very top, you have your leaders talking about like business outcomes and coming up with like success, really what is high level success criteria? What do we want to enable the business by doing these things? Which ends up being boiled down to like a sort of like a cloud strategy or a program or something that's kind of like long term. And then from that, you have to, you build and a cloud network operating model is derived. So for this one, we have a few milestones. We establish something and then we standardize on that something and then we just innovate iteratively. So in taking the establishment or the establishing side of this, so if you look at infrastructure as code, maybe that means just getting the foundations right, just building some templates out and doing some small things and familiarizing yourself with this tool. And then with the multi-cloud networking with Alkira, maybe you're going through and you're connecting your clouds and you're getting that baseline or that bedrock we talked about earlier, sort of just the design in place. And then going up to the higher layers for the application, the layers 4 through 7, service registry and discovery with a service mesh, just kind of getting familiar with that, seeing how it works, and then seeing how these pieces fit together. And then after you do that, you're going to want to standardize it, because automation, any type of automation in any circumstance without standardization could be a recipe for disaster. You could do some serious damage And standardization is just a hallmark of automation. Standardize as much as you possibly can. So for Terraform, that means compliance and governance, using something like Sentinel, maybe to bake in that security policy in the infrastructure as code and create like a set of guardrails around this. So that way you can enable your developers to actually move quicker, but responsibly, and have those guardrails in place so they can't mess anything up unintentionally. And then going up and doing the same thing with Alkira. So unifying that network and security policy and building a scaffolding that can be used for all the business use cases. So when you're onboarding networks, you drop it into the right policy and you already have the policy and the outcomes built. So you can move up to the network middleware automation point now. So this is basically middleware, the components, just basically figuring out how to subscribe them to to do service changes from the registry, and then use automation around that, so you're not doing it manually. And then the innovate stage. So at least in every senior leader's slide deck I've ever seen, self-service infrastructure is huge. This is where we want to get. This is a North Star. So how do we get that self-service going? And that's, we have the compliance already set up. We have the Sentinel, some golden templates, maybe some modules. And, we're going to wrap these things up and use, like Terraform Cloud Workspaces and maybe a private registry of modules that we publish for different lines of business to use or different product teams. And then going up to having that network connectivity bedrock, any-to-any connectivity. So as new networks are getting onboarded, we're just dropping them in the right bucket, and all the network controls are there for them to connect from and to wherever they need to go. And then going up with the service mesh again, controlling, the 4 through 7 for how different, parts of the application, the services talk, share data, how the encryption is set up, and having that control for the real, the micro segmentation. And all this to the point of having that automated cloud agnostic delivery for the whole network stack, unifying that network design policy and visibility across the cloud providers, and ultimately having a common logical architecture, enabling that rapid innovation, because the journey, it's a journey, but it's never done. This is going to continue and continue and continue and change and evolve. So there's never a stopping point. And with that, I'm going to turn it back to you, David.
All right. Well, that was a lot. I personally have learned a lot by just listening to you, and I really appreciate how you provided the enterprise-centric point of view around these topics that may not be very mainstream yet for a lot of enterprises, of how using infrastructure as code, and how marry those constructs with the network and security delivery in the cloud. So I know that many of the enterprises are still sort of trying to figure out their way, and I think your view of how enterprises can leverage the power of infrastructure as code with our Terraform integration, I think that's awesome. Sort of awesome news for a lot of enterprises still struggling through this manual CLI configs and outdated network architectures. So I thank you for that, William, and Michael, thank you for being our partner for this webinar, and in general being partner, supporting our partnership between Alkira and HashiCorp. So I wanted to also thank all of our viewers and listeners. Thank you very much for all the questions that were submitted. And here you can see a couple of ways that you can get in touch with us, starting from alkira.com, our website. And you can also reach us on social media, and of course visit our YouTube channel, where this presentation or this webinar recording is also going to be posted. So you're welcome to visit that and consume more videos that are posted on YouTube around different events and that we've done in the past, and also things around use cases that are supported by the Alkira solution. So again, thank you very much, William and Michael. Thank you very much for all the attendees, and have a great day.